Ladies and gentlemen, welcome to Orlando and SAS Global Forum 2012. Please extend a warm welcome for the CEO of SAS, Jim Goodnight.
Well, good evening and welcome to SAS Global Forum. You know, being back in Kissimmee reminds me of the very first SAS user group we had. It was here in 1976. It was organized entirely by the users, headed up by a gentleman named Julian Horowitz, who worked for Abbott Lab. And we were still at the university, and when we came down, we were greeted by an audience of about 300 people. Needless to say that that got us starting to think about, you know, this company, if we formed a company, it could probably grow pretty good. And we were certainly being stymied there at the university in being able to grow anymore because we were out of offices and a number of other things. But anyway, we did make an agreement with the university, and we left in the summer of '76. And we have been continuing to grow every year. As a matter of fact, this past year, our revenues hit $2.7 billion. And that's over 55,000 locations, customer locations worldwide. And this year looks pretty good as well. And we've got such exciting stuff I want to talk about a little bit later. You'll see why I'm very optimistic about the year. One of the things that happened this past year, we were recognized as the third best place to work in America by Great Places to Work Institute. We had been number one the previous 2 years, and we had to slip down to 3 because they won't let you do it three times in a row. I mean, people would probably quit applying if they did that. So anyway, the top 5 have to rotate around and take turns. But we did, in fact, the same group recognize SAS as number 2 best place to work globally. Of all global international companies, SAS was ranked number 2 in the world. So we're very proud of that. And all of these countries listed on the screen here have received Best Place to Work awards. Most of them in the top 5, top 10. Several are even number 1 in their country. Another thing I'm really proud of is our continued development of SAS curriculum pathways. Now this is a little bit unusual for us because it's really targeted at the K-12 audience. And it's digital text, or digital content is the right word, digital content that is available to any child in the U.S. and teacher free of charge. So if you're not familiar with this, and we've won a lot of awards with it, you can go to www.sas.com and look up curriculum pathways, and you can learn more about it. So as you saw from the opening, this idea of big data, the deluge of data, well, it's really nothing new to SAS. We've been dealing with big data all the time. You know, we'd have to do some sampling to get the size down to be able to analyze it, but we still have been dealing with it. But about 3 years ago, I was over in Singapore, and a banker told me it was taking them 18 hours using our SAS's risk solution to compute the value at risk. And he said, we've got to find some way to make this happen faster. So what we did was, I came back, I thought about the problem, I talked to our risk people about exactly what it was they were computing, it was taking so long, and then I went to our advanced computing lab and had some of our really, really smart folks there start thinking about how do we break this thing apart. Instead of using just a single processor, what if we can use 1,000 processors all running in parallel? And that has to be the answer to this problem, because the number of computations that have to be done is just enormous with all the simulations and everything. So anyway, that 18-hour job now runs in 12 minutes. So that's the amazing thing. Now, Oliver Schauenberger is one of our key developers. And Oliver, why don't you show him some of this high-performance analytics?
My pleasure, Jim. When you came back from Singapore and told us to get working on this, we did listen, and I'm happy to report that in December we released our first version of high-performance analytics to product. And the premise of this product is simply to bring big data and big analytics to the desktop and to your SAS session. So in this particular case, I'm running a problem that a customer asked us to solve, a big variable selection and logistic regression with 1,500 variables. They wanted to do a backward selection because they also wanted to fit the full model. And we've transferred the data from a Teradata database, and you can see on this grid monitor behind me how the 24 cores per little blade in the appliance, each rectangle represents a blade, are busy, and something has stopped, and we continue to go. So this is a problem that would take very, very long time, and you can now run this essentially from your desktop and interface with your SAS session the same way you are doing today. So all the output is coming back here, all the ODS is available, output data sets and so forth. We simply, if you will, high performance enable the SAS language to take advantage of a big data appliance.
So when you put HP on the front of a PROC, that means do not run the analytics here on this server that we're currently running on, but rather transfer over to one of the big appliances like Teradata or Greenplum and run it over there, pulling the data straight in, off the database, straight into memory, do the analysis, send the results back.
It is a co-location model, and that's really key to the success here. We can tackle very big problems in terms of the analytics because we parallelize the work so much, and we co-locate the analytics with the data provider, so we avoid data movement, which continues to be the #1 performance killer. So while we were just chatting, I fired off another job, and I ran a logistic regression with 1 billion records, and that just took about 32 seconds. And
how long was it?
32 seconds.
Oh, you're getting slow on us. It was only 1 billion records.
Well, we like to call the billion the new million. And that's really not so far-fetched. If you imagine you have 24 units of work on each blade, if you had 48 blades, that's about 1,000 or so, right?
1152.
Thank you very much.
I've got that on a slide later on. That's how I know that.
So if I had 96 gigabytes of RAM on 48 blades, then I had a lot of memory, yeah, about 4 terabytes.
4.7.
Where were we?
So
we're running these jobs that would take a long, long time. Basically, like as we're chatting about the problems, and they're finishing. So what we've done here in about 2 minutes would take you over a day, not just a work day, a day probably to run this in a regular environment, a non-high performance environment.
Well, I think a billion records into a logistic would probably take more than a day. I mean, that's a lot of iterations that have to go and a lot of I/O. By leaving the data in memory the entire time, when we're doing those second and third iterations, there's no I/O because the data's already in memory.
So now I remember why the billion is the new million. Because if you have 1,000 units of work, each of those units of work sees a 1,000th of the data, which makes it appear as if you are really working on a problem 1,000th of the size. And if you noticed how much CPU utilization we achieve on the little grid monitor, we are really pegging the CPUs. That means we get a very high degree of parallelism, and that allows you really to scale the problem. So for our customers, whether they have a big data problem or a big analytics problem, these environments are incredibly useful, even if you don't deal with 1 billion records. you might benefit greatly from the degree of parallelization that we can offer.
Well, today the first thing a person would do confronted with 1 billion records would be to try to do some sampling to get the problem size down, run that smaller problem, verify that the model works on some test data, and then go use that model to go out and score. You don't have to sample anymore. Give us 1 billion, we'll do it. No problem. So
the key is to build better models, to be faster in getting to, your models, and to get lift from the ability to reevaluate a model after you fit it. In the last little job I ran, we take 2,000 variables, do a supervised variable reduction to get me a set of 200 most important variables, and then we really apply a high-end analytic procedure, the lasso variable selection, to nail down the fitted model. And we can do this in just a matter of seconds or a minute.
Well, very good, Albert. And you'll be hearing a lot more about this.
There will be a number of demos on high-performance analytics product. There will be super demos and, of course, talks. And can we say that there will be more seen tonight?
Yeah, I'll be back later to talk a little bit more about this and actually show you some of the inner workings, how some of this stuff works.
Thank you.
Let's have a warm welcome.